Okay, the question gave us these two columns here, the weight and frequency. And we have to work out the cumulative frequency, which corresponds to this column here. So, the cumulative frequency, you just add the frequency numbers up as you work your way down. So the first one is always the same. So 4 plus 7 is 11. Then 11 plus 21 is 32. And 32 plus 21 is 53. 53 plus 18 is 71. 71 plus 7 is 78. 78 plus 2 is 80. Okay, that scratching sound is my little dog who's down here right now. She may say hello later. Okay, so that's how you do cumulative frequency. And now we have to plot the cumulative frequency against the weight. So what have we got? Cumulative frequency of 4 for the weight of 40 to 50. So you use this value on the x-axis, the uppermost value of the weight. So we're going to plot 4 against 50. So 50 here and 4 there. Okay, here 60 and 11. So 60 and 11. 70 and 32. 70 and 32. Yeah. 53 and 80, or rather 1853. X 80, Y is 53, which is about there. 90 and 71. 90 and 71 is there-ish. 100 and 78. 100. Oops. Okay, 100 and was it 78 is about there. And 110, 80. About there. Okay. And you join them up in a smooth curve as you can manage. Okay, that was pretty rubbish, but it's good enough. Should have really gone through that point, but I've done this by hand. I'm not sure that point was plotted brilliantly accurately. I hope you get the idea anyway. Okay, next bit. Now we have to give or work out the number of people whose weight is greater than 85 kilograms. So what you do, you find 85 kilograms, which is there, and you go up and along. So, up and along, and you get about 62 here. So that means, now remember the question is saying how many adults have a weight greater than 85 kilograms. The answer isn't 62. The answer is however many adults are in this region here, from 62 to the total number. So it's actually 80 minus 62. So 18 adults have a weight greater than 85 kilograms. Again, I've done this by hand, and the examiner's looking at the answer sheet. You're allowed a little bit of leeway in the answer here, because you might have plotted a slightly different curve and so on. But the number around 62 is what you're looking for. Okay, next. We have to find the interquartile range of the weights. To do this, you do this. First thing is to find the lower quartile. So look at the cumulative frequency and move a quarter of the way up. A quarter of 80 is 20. You then go across and down and read off that value there. And on my particular graph, it looks about 65. Okay. And then you find the upper quartile, which is 3/4 of the total. So 3/4 of 80 is 60. And go across and down. That's not the best line in the world. Okay, across and down. And that looks to be about, say, 83. Okay. And the interquartile range is that minus that. So in my case, it's 83 minus 65, which is 18 kilograms. Okay. Now, looking at what the answer sheet, the examiners say, they allowed anything between 18 and 22, because again, there's going to be a slight difference in your graph, and you might have a slightly different value. Well, you're going to have exactly 20 there, but you might have a slightly different value here because your line is slightly different, and here. So this bit's going to be different slightly, maybe. Anyway, they allow anything between 18 and 22, and I've got 18, so that's fine. 18 kilograms. Good. Okay. So that's it. That's how you do interquartile range. Summer, come here. Come here. There's a good girl. There's a good girl. There she is. There's the scratcher. What do you think of that? Yeah, not much.